It is showing. Oh, no. Okay, so now the recording has started, so no problem now. So student, we will start with our first unit. Okay, and let's see. I will share my slide with you now. This is okay, generating station. So students, have we discussed this generation technologies in power system 1 or no? Students, I'm asking that at any point in during the study of power system 1, we have discussed this thing, power generation technologies or no? Students, you can hear me or no?
Yeah, Doc, we can hear you.
James.
Yes, Doc.
Hey James, how are you? Hey, I was thinking that you have not registered for this course. So you already gets irritated with power system 1, so now you was thinking not to enroll for this course, power system 2.
No, Doc, I'm here. I'm ready.
Okay, thank you so much. Thank you so much. So, student,
just for your question, you might need to explain more of what power technology generation is, or just maybe explain what it is first, and then we can kind of tell you whether we did it last year or not.
No, I'm sure that because in last year I have teach to you as well as some of the industry guys power system 4, and the content is almost similar. So that is why I'm not sure whether I have discussed this part with you or I have not discussed with you. So that is why I'm asking whether I have discussed with you this part, because if not, then I will discuss in the detail. If yes, then I will try to be as short as possible, because this is the first unit, the power generation technologies. Yes, James Pillay, are you here?
Yes, yeah.
Yes, Pillay, you are sleeping in the morning. Students, you can hear me. I only need the answer.
Yes, sir, we can hear you.
Okay, I only need the answer that whether we have discussed this thing earlier or no. This is the first time.
First time, sir. It's the first time. We didn't discuss it.
Are you sure?
Yes, we have not discussed this. Maybe we are discussing it with the other class.
Okay. Thank you so much. Thank you so much. No problem. No problem. Okay, so now we start with our first unit, that is power generation technologies. Okay, today is our first class, so we will try to go slightly slower, but then we will try to go as with our speed so that we will be able to cover the complete contents and all the PPTs, and I will say is all are well developed, so there's nothing you need to worry. Okay, and it's also a very easy module. Only concern is that try to get the knowledge. Okay, so I will start now. The first thing is that we'll start with what do you mean by, you can see my screen, students?
Yes, Doc.
Okay, no problem, because you see that today the network is coming and going, so I don't want that I should speak from here and you're not able to hear on your side. So please, if any point if I will ask you, so please confirm me. So now you see that power generation technologies, that's very important, student, and that's this first unit. I believe that this part need to be discussed in power system 1, but the modules are designed as per the EXA requirement, and the power generation technologies means that how a power is generated in the how a power is generated in the power system with the help of different sources. Okay, so you know that in our country South Africa, mainly the Eskom, they are responsible to fulfill your requirement of the power. Okay, and today we will see and I will show you that Eskom totally rely on the thermal power plant to fulfill your requirement. And every day you hear that the Eskom has announced the load shedding. There was one of the unit that has some breakdown, one of the unit trips. Sometimes the coal is not available. Sometimes there is a fault in one of the units. Sometimes there's a fault on the turbine system. So we will try to see now that because we cannot go into too much of the detail considering your the module requirement, but now we will see that how and which kind of the sources are used by the Eskom in South Africa to meet your power requirement. But we will not only focus on one sources, we will focus on thermal. That means we will focus on the coal, we will focus on hydropower plant, we will focus on the nuclear power plant, and in the last we will focus on the gas power plants also. Okay, so now we'll start. First thing is that before going into anything, the first thing always come into the mind that what is the importance of the electrical energy, why we need an electrical energy to fulfill our most of the requirement, okay, or most of our needs. So first thing is the convenient form. You see that, guys, you are sitting in your houses and you're getting the energy, okay, and you do not need to do anything, only you are just paying, and you are also not paying a too much amount that every customer is not able to get this kind of the energy. So it means one of the things is that the convenient form, whether the power is going to the domestic houses, also the power is going to the industries, also the power is also going to the different malls, also power is fed to the different they are very different types of the industries, like they are the power industries, they are the control industries, they are the sugar mills. So everywhere the power is going as per their requirement. It totally depends upon what voltage or what kind of the services they require, whether they need a single phase power, that is most liable for the domestic houses. But if we talk about the industry, they always need the 3-phase power as per their requirement. And some of the major industry, they straight away say to the ASCOM that we need the 11 kV power or maybe the 33 kV power, because they have the different units that run into the parallel, so they need the higher voltage as per the requirement. Another thing is that students, second point is easy control. Easy control means in our power system, and I don't know if you have read about the machine, we have the motor, generators and transformer. These machines are the heart of the power system, or I will say these machines are the heart of an electrical engineering. And if you see that in your houses also, if you have seen a motor, or maybe in industry or in a lab, you can see very easily that you connect a socket, okay, into the switch, you switch on the supply and the motor will start. You don't need to do anything. Whenever you want to switch it off, you do not need anything from that motor, you can switch it off also. At the same time, if when you will go into the industry or into the lab also, okay, so you will see that there's also possible to control the speed of AC motors as well as the DC motor also. Okay, so that's one of the best concern, that is that the electrical energy, okay, whether it is generated with the help of a generator or we are converting the electrical energy into the mechanical energy with the help of any motor, is very easy to control. Okay, so that is one of the, I can say, the important concern. Third thing is that greater flexibility. Flexibility means that, guys, you see that you never know that what actually is going on in the power plant, what excom engineers are doing, how they are able to generate the energy, how they are able to meet your requirement. And sometimes you see that there's a load shedding and you guys say that no, it's very difficult for us to manage. For us also it's very difficult to manage, but you never know that how they are managing the system. So flexibility means that the power is generating at the remote areas where you guys cannot, where you guys, it's not possible for you guys to just go there and see what actually is going on there. But then also you are getting the power and you never know, and you are never worried about that what actually is going on into the different power plant, how the power is generated, how it is transmitted, okay, what is the level of the voltage, what is the level of the current, what kind of the protections they are following. Okay, so that is the greater flexibility. Another concern is that greater flexibility also come, and the greater flexibility and your last point, high transmission efficiency, they both resemble the same thing, because you see that the power is generated, if I talk about the thermal power plant, it totally depends upon the coal. Okay, so if the sufficient amount of coal is available, then only you will be able to generate the electrical energy. But you see that the coal is available near to the coal mines, so we always design the thermal power plant near to the coal mines, where the coal mines are available, so that the transportation cost will be minimum. Okay, so that is a concern. And you see that when the coal mines are available almost 1,000 kilometers or 2,000 kilometers away from your houses, and then you need to transfer that energy, electrical energy, with the help of this transmission line. If you remember, in the power system one we have discussed, in the power system one we have discussed about the various types of the transmission line: short transmission line, medium transmission line, and long transmission line. And you have also seen the model of the T and pi model. And if you remember, we have seen also this thing that with the help of the transmission line, the major part of the power or electrical energy is transmitted from that power plant to the load center. It comes to the various substation. We will also discuss those things in the later units, in the second or third unit, that how that power is transferred with the help of the we know that how power is transferred with the help of transmission line, then how it reach to which kind of the substation, whether it's a primary substation or it's a secondary substation, and after this how the power is finally distributed to the consumer. So you can see that the greater flexibility means, or high transmission, that efficiency means that most of the power is transmitted. And then also still we have discussed that transmission lines have some losses, but then also it is possible that our system is so efficient that 97 to 98% of the power is transmitted from your power plants to the load center. Okay, so that means the greater flexibility and high transmission efficiency. Another concern is that cheapness. Cheapness means you know very well that how much you pay for a single unit. Okay, so the electrical energy, I believe, is much cheaper in comparison to, if you compare it with some other sources of the energy, maybe the heat energy, mechanical energy, or some other sources of energy. Cleanliness means that when you're sitting in your houses and you're using the electrical energy, there's a no smoke, no fumes, nothing available. Okay, so I can say that the electrical energy is the cleanest source of the energy. I'm not talking about the power plant right now. You're only talking about that what is an importance of electrical energy. Okay, so that's the first slide we have covered now. Another thing is that you see that, and you know this concept, that electrical energy, and I don't know whether the other lecturer have discussed with you that what is an alternator means, or I will say that it is a generator. It's a three-phase generator. Its shaft is coupled. This is a bearing. The shaft is coupled to the prime mover. The prime mover may be any three-phase induction motor. We give supply to the prime mover. It's a three-phase, I will say, the induction motor. On the shaft, this is the shaft. It is with the help of the bearing, it is coupled to the shaft of alternator. It will start rotate as soon as we will give the supply from here. As the motor will start rotating, the rotor of this alternator, the alternator will have the two, I will say, aspects. One is the stator, which is the outer part of the machine. It has the three-phase winding, as well as the rotor. Rotor also has a winding. So when the rotor will rotate into a stationary magnetic field, then there will be an EMF and a three-phase supply is generated. The name of the three-phase supply, we have the different phases. The first name is given as red, yellow, and blue. Okay, so this is a very simplest example that how to generate an electrical energy. We are not going into the detail whether it's a synchronous generator, it's an induction generator. So that is not my part. That will be discussed by the lecturer from the machine or something. Okay, and so that's one of the concern. Now we move to next slide, that energy utilization. So this is the picture of your South Africa, that if you see this, the representation, you can see that here most of the energy requirements met through your coal. Okay, after this we rely on the crude oil. If you can see the green part here, then we have natural gas, hydroelectric power. Very less aspect has been seen also in South Africa. We will discuss today also, if we got the time, that what are the capacities of the power plant and how much power we are generating. Then we have a good, or I will say the slight amount of the nuclear power. And now, because the South Africa has a very good, I will say, the scope of the solar radiation available, we have a very high intensity of the solar radiation available. So now the South Africa is moving toward whether we will be able to meet our requirement with the help of the photovoltaic PV panels, or with the wind power, with the tidal power, with the geothermal power. But mostly the South Africa totally right now is working in the area, and a lot of research is going on in the areas of the solar power, that is the PV, okay, as well as the wind power. And wind power, there are the two types of the turbine. One is the horizontal axis, and it is the vertical axis wind turbine. Okay, so that's one concern regarding the energy utilization of the South Africa. Another thing is that if we talk about, we have already discussed that in South Africa, the Eskom is totally dependent on the requirement to generate the electrical energy with the help of thermal power plant. And in thermal power plant, the coal is burnt to produce the steam, at high temperature. Okay, so the requirement of the fuel is coal. And here I have tried to show that the total thermal power generation, thermal power means the plant where the energy is generated with the help of the coal, okay, and the steam is produced. We will discuss those things now in a detail. So we have the total capacity of thermal power generation. Maybe if there is a slight change in the capacity, I don't know, please check from the Google if there is some slight change, but my knowledge, as for my knowledge is concerned, 40,036 megawatt is the total installed capacity of the thermal power generation in South Africa. We have the major power plant, Duhawa power station, having the 3600 megawatt, Kendal power station 416 megawatt, Royal power station 3000 megawatt, and Majuba power station 4110 megawatt of the power generation, including the total is 40,036 megawatt, and the major plants are in South Africa in this region. Okay, so this is a number for that, how we will see after this also, when we'll completely discuss about the thermal power plant, that what is the number for hydropower plant, the nuclear also, and then we will see for the gas power plants also. Students, any confusion till now? Any confusion, any question you want to ask? Students, you cannot hear me.
We can hear you, Doc. No confusion.
Okay, okay. Thank you so much. Thank you so much. So, thermal power station. Now we go into the detail of thermal power station. Now you see that before going into the working of the thermal power plant, first is very important to know that why most of the power generation is done in South Africa with the help of coal only. Okay, so one of the earlier reason, I will not say that right now this reason is valid, okay, because now a lot of research is going on and we are shifting to renewable energy resources, because we believe that the coal will finish one day, then how we will be able to meet our requirement. So first thing is that the fuel coal used is very cheap in comparison to other sources, okay, such as the nuclear power plant, or I will talk about the gas or some other sources. So they believe that the fuel used is quite cheap. That's one of the first advantage. Another thing is that you see that if we talk about the thermal power plant, okay, the initial cost, there are the two types of the costs that are associated with any power plant. One is the initial cost, another is the running cost. Initial cost includes the setup of the plant, buying a land, setup of the just recruiting the number of the engineers. You need the labor to set up each and everything, which include the infrastructure, as well as your buying of the turbine, generator set, and the different equipment. So that includes the initial cost, but the running cost includes the maintenance as well as the fuel cost. So if we talk about the thermal power plant, and if I compare it with the hydropower plant, then the initial cost is very less for thermal power plant, because if you go into the hydropower plant, in hydropower plant, one of the concern is that the water is used as a fuel. So that is why you need to store the water in a sufficient quantity with the sufficient head, okay, to run that plant successfully. And that is why you need to create or construct a dam. So that is why the initial cost, if we look into the thermal power plant, the initial cost of thermal power plant is very less in comparison to, if I say, the hydropower plant. Another concern is that we have discussed this thing, mostly the engineers or the maybe the country always try, or the Eskom always try to install these places or in these plant near to where the coal mines are available. But then also, if the coal mines are not available and we get the land at the cheaper rate, and we feel that that land has a good bearing capacity of the different machine, then that land can be chosen irrespective of whether the coal mines are available there, and then the coal can be transported to the site of the plant with the help of the rail or the road. But it should be, or I will say it is very important that that place should be accessible with the help of the rail as well as the road. Another point is that it requires very less space in comparison to hydroelectric, as we have discussed. Third, next point is that the cost of generation. You see that we have sources where the people use the diesel power generator, and the diesel is much costly in comparison to the coal. So I can say the cost of generation is lesser than that of the diesel power station. Another concern is greater flexibility. This point has again come, and we have discussed greater flexibility means that the power is generated at the remote location where coal mines are available, and then power is transferred, or I will say power is I will use the transformer only in the terms of an engineer, that the power is transferred with the help of the transmission line to the load center and to the various substation, primary substation or distribution substation. Okay, so we have the greater flexibility with the thermal power plant. Another concern is that some of the disadvantages are that it pollutes the atmosphere, because you see that when we burn the coal, then the large amount of the smoke and fumes will be produced, and then what we do is that it's not the case that we straight away discharge that smoke and fumes into the atmosphere, into the upper atmosphere. If you pass from some of the areas, you see that there are the plant and there's a long chimney, and then you will see that a lot of smoke and fumes are coming out. Okay, but we filter that thing before discharging into the atmosphere. Otherwise, what will happen? The atmosphere will be totally polluted, and then when you inhale that air, then your lungs will be infected. So that is why. But then also it's not possible to 100% filter each and everything. It has some pollution in the atmosphere. Another thing is that you see that this plant is need a coal every day. Okay, so that is why it is very costly in running in comparison to hydroelectric power plant, because for hydroelectric power plant the water is used as a fuel, and mostly the people, they believe that water is very cheap and it is easily available also. Okay, that is the earlier thinking, and that is why the hydroelectric plants were developed. Another concern is that the efficiency of thermal power plant are very less, because here by burning the coal, heat is generated, and then that heat energy is converted into the electrical energy. So we will see all those things. So that is why, and heat is lost in every stage, and that is why the efficiency is very less for the thermal power plant. Okay, that's one concern. Now this is the important, and it's very important. We will discuss this thing. This is the complete, I will say, the layout of the thermal power plant. Okay, and we will see the operation also. But if you see this, I will say the layout of the schematic, then it is very difficult to understand like this. So I will divide it into the different parts. First, try to see that this is the coal and ash handling plant. We will discuss this thing also in detail. This is the coal and ash handling plant. That's one part of the thermal power plant. Okay, this part is the part where the few gases are used to heat the water in some form. Okay, we will discuss that thing in detail. I'm just only giving you a slight idea. This is the part where the turbine is coupled to the generator, and then the power is fed to the grid, RYB. This is one aspect. Another aspect is this is the condenser, or I will say condenser or condensation stage, where the exhaust stream is condensated with the help of the water from the river or canal. Okay, so that you guys will not get into confused, and whatever is the few gases, they will discharge into the upper atmosphere with the help of a long chimney. It has a filter also, electrostatic filters they have, so that they can just track each and everything from that few gases before discharging into the atmosphere. So you have to understand, we will see these things in a detail today. First is, as I discussed with you, coal and ash handling arrangement. steam generating plant, because this plant work on steam only, on high temperature steam. We will discuss steam turbine. This is an alternator, feed water and cooling arrangement. So if it will be asked from you in exam to discuss the operation of the thermal power plant, you need to discuss these aspects. If this question will come for 15 marks or 20 marks, that coal and ash handling arrangement, steam generating plant, steam turbine, alternator, feed water and cooling arrangement. Now let's see, let's go back. Okay, so now you see that student is very important. Okay, and it's very, I will say that before going into anything, you should understand that, just a second. So first we will start with your this part, that cold storage, coal handling plant. Now you see that student, for any, I will say, successful operation of the your thermal power plant, you need a coal. And what the ESCOM guys they do in the thermal power plant, they get the coal from the coal mines, okay, and then they store this coal into the, there is a storage plant available into the thermal power plant where they store the coal for almost 1 month. Why they do this thing? Because if there is some kind of the transport strike, if there is some strike in the coal mines, and if the coal is not available, then they won't be able to generate the electrical energy. So that is why they get the coal from the coal mines, and with the help of the rail as well as with the help of the different trucks, the coal is transported to the thermal power plant where it is stored in the abundance. They try always that they can store the coal for almost 1 month. Okay, so that is known as the coal storage. Okay, so that is one of the thing. After this, the coal is shifted to the coal handling plant. Now you see that here there is a conveyor belt. There is a conveyor belt on which the coal will move. You see that you cannot shift the coal because the coal sizes, okay, it is available into the different sizes. You cannot feed that coal straight away into the boiler. No, that is not possible, because you need to burn that coal also. Already the plant is having a very less efficiency. So that's why it's very important that the coal is break into a smaller pieces in the coal handling plant. Okay, that is known as pulverization. I repeat, that is known as the process is known as pulverization, where the coal is break into the smaller pieces, because if the pieces are small, so when it comes into the presence of the air, it will quickly burn. Okay, but if the pieces are very big, okay, because you have seen some, I don't know if some of you have seen the coal pieces, okay, they come into the different sizes, then it will be very difficult, or you have to work a lot here in the boiler to burn them. So that is why the coal is burned into a small pieces, and then it moves into the conveyor belt and fed into the boiler. So that is one thing, that from coal storage plant, it is handled, or I will say that it is delivered to the coal handling plant where it is crushed into the small pieces for proper burning. The pulverized coal is fed into the boiler with the help of a conveyor belt. There is a conveyor belt on which the small pieces, the crushed pieces, are just put onto that belt, and it always move. It's always move continuously, so it can fit the coal into the boiler. That is one is the concern. The coal is burnt in the boiler. That's very important. Then the coal will be burnt in the boiler. Then on the regular basis, the ash will be produced. Okay, and another concern is that if you will not remove this ash from the boiler, then what will happen? Ash will get stored, and then it will take most of the space of the boiler. So that is not good. You need always that there should be the sufficient space available in the boiler so that you can just fit the coal into the boiler. So on regular basis, that ash, okay, that has been generated by burning of the coal is taken out with the help of the some process here. They always take the ash from here and sorry, they always take the ash from here, and then they deliver it to the ash handling plant. Okay, in ash handling plant, they store the ash on regular basis, or I will say on the regular intervals. They remove the ash from the boiler, they take it to the ash handling plant, and with the help of ash handling plant, finally they take the ash to the ash storage, and after this they dispose it, okay, on the regular basis. So that's one of the concern. Another concern is that, student, that's very important, that now we have discussed this part, we have come here. Here is the boiler. In boiler, one of the concern is that the coal is burnt. So when coal is burnt, okay, there are the tubes, in the boiler in which the water will run. Okay, water will run. So our aim is that when we burn this coal, okay, so with the help of, because there's a water also in the boiler, so with the burning of this coal we will able to convert that water into the high temperature steam. Okay, but by burning the coal, because first I'm going into this stage, we will come back to this stage also. Okay, by burning the coal there are some flue gases, okay, which will travel, okay, which will travel through here, and then it go to superheater. Okay, it will go to superheater. From boiler, you see that when you burn the coal, okay, so the water is available in the small tubes, and they are the pellet tubes. Okay, they are very fine pellet tubes, so the water is converted into the steam, but that steam is still wet. You cannot allow that steam to fall into the turbine, because it will make the blades of the turbine corrode, or at the same time it is also possible that when this steam, which is not completely dry or superheated, can lose its temperature, and if it converts into the water, then it can damage the blades of the turbine also. So that is why it's very important that the steam which has come out from the boiler, okay, by burning the coal, is superheated. Okay, is superheated, and it is completely make as the dry, okay, on the superheated temperature with the help of these few gases. And after this steam, with the help of these a steam valve available. This is was a valve so that you can control the pressure of the turbine, pressure of the steam also, because it depend upon how much valve you will open, because you have the steam which is coming from the back from this point. Okay, now it's very important to regulate that steam. Okay, so this steam will fall into the turbine, it will rotate this turbine. The turbine is, this is the bearing is coupled to the shaft of the alternator. A three-phase supply is generated. Okay, now this is an arrangement of a three-phase alternator. It has an exciter, and this is known as an alternator. Exciter, I don't know whether you have read in the machine, exciter is used in, you can say, the three-phase synchronous generator to maintain the excitation. Synchronous machine is a doubly excited machine, so once there is a locking between the field as well as the rotor, then it tries to maintain, or it will always run on the continuous speed only, whether it's a generator or it's a motor. That is why an exciter is required in a three-phase synchronous generator. This alternator or generator is coupled to the transformer, so that whatever the voltage is generated, mostly the thermal power plant, they generate the voltage at 11 kV or maximum at the 33 kV, because they cannot go beyond that limit to reduce the cost of installation. Okay, otherwise the cost of installation will increase. So there is a transformer, there's a transformer here. It will step up the voltage which is available here. After this, they are the isolators. We will discuss this thing, don't worry, that what you mean by isolator, and there is a circuit breaker. So I will give you a slight hint here that isolator is a kind of the switch. Okay, as you connect this point, this point, this point, the power from this transformer straight away reach here. Here there is a circuit breakers again, and there are the isolators. Okay, there are the isolators available on this side also and this side also. Why the isolators are provided? The reason is that, student, that if there's any fault on this side, then this part can be isolated by opening these switches. At the same point, if there's some fault here, then these switches can be open and this part can be saved at that time. So that is the protection of the power system. Okay, and in between there is a circuit breaker. We will see that how much time we will get to discuss that what are circuit breaker, what's the difference between an isolator and circuit breaker. I will tell you one thing right now in a very simple language, that isolators cannot be open on all load, but the circuit breaker has a quenching property, in which if the load is still connected, they can be open at any stage and can isolate the unhealthy part of the system with the healthy part of the power system. That is the beauty of the circuit breaker. We have different types of the circuit breakers, but that is also not the aspect of this power system. So we'll see that what we need to cover. So that is one of the things, student. So we have reached this part, that there is a valve available here. You can regulate the pressure of the steam at any point, because it depends whether the load requirement is high, the load requirement is normal, or I will say the load requirement is less. According to this, you have to regulate the pressure of the steam. But for this pressure of the steam, to regulate the pressure of the steam, it is also required that you have the sufficient coal, so that the steam is available with the help of superheater to the wall. That's one of the concern. So the coal is burnt. You see that heat of combustion of coal in the boiler is utilized to convert the water into the steam at high temperature and pressure. The flue gases, okay, the flue gases from the boiler, they goes to the through superheater, then they will go to economizer, and then they go to air preheater. Okay, we will discuss these things also now, that what is the reason why they are going to the superheater, economizer, and the air preheater also. Because one of the concern we have discussed, that in, you see that your the flue gases which goes from boiler to the superheater. Why? Because the steam produced in the boiler is wet, we have discussed, okay, and the wet steam from the boiler is passed through the superheater, where it is dried again and superheated with the help of these flue gases only, because you will not be able to utilize these flue gases totally. So the sum of the gases which has been taken from here, it has been used to heat these this steam on the superheated temperature, and they are dried before feeding into the turbine through the main valve that we have seen. Now whatever the flue gases which has been left, okay, they will go to economizer. Now what actually has happened, the water is fed with the help of feed water heater and feed water pump will pass through the economizer. Okay, now the water which is coming from here, only try to understand this part. When you will see this video later, you will understand in a better way. The water is taken from the canal or the river, or sometimes when the water is not available, it is stored in the cooling tower also. So the water is taken, okay, from this river and the canal, and first it is treated. Treated means the water will have the different types of the minerals, it will have the different types of the calciums, and different types of the, I will say, it also has a salt, so which can corrode the blades of the turbine. So that is why it is always treated, and the filtered water is given to the feed water heater, where the feed water heater, there is a feed water pump. It takes the water from here, from this water treatment chamber. It takes the water from here, then it passes through the feed water heater. What we do is that feed water heater, we heat the water so that the water which will go to the economizer and finally go to into the boiler is always hot. So you do not have to, the boiler do not have to work a lot, or I will say we do not, in boiler there's not too much of the heat is generated, so that we need to just increase the temperature of a cold water, then to make it hot, and then finally to make it to the steam. So that is why the water is taken. It is first it is filtered here, the water is filtered, then with the help of the feed water heater, the engineers, they make the water hot, and then they feed it to the economizer. And economizer, the flue gases which are available at the output of the superheater will pass through the economizer. So in economizer, basically what is that economizer, the role of the economizer is that the water which is already in a hot water, which is coming from the feed water heater, is again heated so that it becomes more hot, again heated with the help of these flue gases before feeding into the boiler. I repeat, the flue gases which are available at the output of superheater, when we have dried the steam, we have superheated the steam, the flue gases, available flue gases will pass through the economizer, where the hot water which is coming from the feed water heater is heated again, so that this water will further gets more hot, and then only it will feed into the boiler. So it means, guys, that the water which is fed into the boiler is not a cold water, it's already a hot water, and now here in the boiler the coal is burnt so that quickly the steam can be produced. Okay, after economizer, the flue gases which are the available flue gases, okay, they are used to heat the air also, okay, because this hot air is going into the boiler. So it means in boiler you have the water, you have the hot water, you have the coal which is burnt, and now you need a hot air also to burn the coal. So that is why a forced draft fan is utilized or used, so that the air can be taken, and then with the help of these flue gases only, you can see that how efficient the process is, that they try to use the flue gases which has come out in the superheater stage, economizer, and then they take the air from the atmosphere and then they preheated this air, and then only they fed into the boiler. After this, the flue gases will go to the chimney where it is filtered, the smoke and the fumes whatever available, okay, through these flue gases it is filtered, and then with the help of the long chimney it is discharged into the atmosphere. That's one concern. So I think now it's very clear to you that what is the role of the superheater, economizer, and air preheater. Now you see that, guys, now we'll come into this stage. Okay, now we'll come into this part also. Now at the output, or I will say at the and there's one more concern. I don't know if you know, there are the three types of the turbine. One is the low pressure turbine. Okay, sorry, first is the high pressure turbine, another is the intermediate turbine, and third is the low pressure turbine. So I don't know in the book if they have given the detail of the three types of the turbine. It's not only the one turbine where the steam is fall. So first it will fall into the high pressure, okay, then it will fall into the intermediate pressure turbine, and then finally it go to the three turbines are coupled in such a way with the common shaft and the bearing, and then they are coupled to the alternator. Okay, and you can see that right now you are seeing here, but if you go into the plant, so you will see that the turbine is having arrangement. It looks like that our complete your one room look like so that it's a turbine. Okay, the size of the turbines are very high because they are generating 3000 megawatt. Okay, so now you see that at the output shaft of the turbine your steam is available. You can see that this steam is utilized to just move this turbine. After this, the steam which is available is at the low pressure and the temperature is reduced. So what actually has been done, that if you see, or I don't know if you've been to any of the plant, so just below this part, okay, there is the basement is created always in the plant, and there they take the exhaust steam and they take it into the condenser stage, where with the help of the cooling water this steam is condensated. Okay, this steam is condensated, but now when you condensate, then some part will be loose into the, or will be, I will say, will go into that. It's not possible to utilize 100% of the steam into the water. So the water which is created here is fed to the feed water here, feed water heater with the help of the feed water pump. Okay, so it's a continuous process, but you see that in this process some amount of the heat is lost into the system. So that is why, to maintain the pressure, to maintain the level of the water is also taken from the river and the canal. Sometimes you see that there's always a variation of the water in the river and the canal through the complete year. Okay, sometimes the level of water is high due to the different weather conditions. Sometimes the water level of the water will go low. So what the thermal power plant do, they create a cooling tower. Cooling tower means that if sufficient water, they take the water from the river or the canal, they filter it and then stored it into the cooling tower. The reason is that if sufficient water is not available, then they won't be able to condensate the exhaust steam which is coming out from the turbine shaft. So that is why it's very important that they store the water into the cooling tower, and then if the water is not available, okay, in the river and canal, then the water is available in the cooling tower, then with the help of circulating water pump it is fed to the condenser, so that when exhaust steam will come it will be condensate, and finally the water will be given, will pass through feed water pump to feed water heater, and then it will go to economizer. So it is a continuous process. It is a continuous process that the coal is coming from here, it is burnt here, okay, then the flue gas is discharged into atmosphere, the power is generated, the exhaust steam is condensated, so like this. So this is the complete process of the thermal power plant. I believe, I hope that you understand that how thermal power plants are working. Okay, so here I have not written these things. I have discussed with you coal and ash handling plant, what actually it is doing, steam generating plant, steam turbine, alternator, feed water, and cooling arrangement. Another thing is that choice of site. It is also an important concern. that when you look for that you need to install a thermal power plant, you get confirmation from the government that okay, you can go ahead and you have the sufficient resources available to generate the electrical energy, and you have decided that okay, I will be able to generate this amount of the megawatt, and for this I need the 3 generators or maybe 4 generators. This is an arrangement what I have shown to you only for 1 generator, but this is not the process. They had almost 2 or 3 generator depending, and then they called it as a unit 1, unit 2, unit 3. When you go into the industry, there you will see all those things. So first of all, the important concern is that supply of coal. That's very important, because you see that the steam power station, they should be located near to the coal mine, so that the transportation cost of the fuel will be minimum. However, if it is not possible, if it is not possible where the coals are available to install the thermal power plant, then what they do is that they transfer the coal, or they transport the coal with the help of the rail as well as the road. Another thing is that the thermal power plant should be located where the sufficient water is available, because the water they need to condensate the steam which is coming out from the turbine, which is the low temperature and low pressure steam. It need to be condensated, and that is why they need the water on the regular basis. Transport facility. Now you see that it's very important. The modern power plants, the thermal power plant, they have a lot of other machineries also. Okay, and if there is some breakdown of the unit, then your transport facility means it should be well connected. Okay, and there should be the transport facility, so that the quickly the other machines can become, the engineers can be brought to the thermal power plant, and the faults can be rectified in the minimum time. Next point is the cost and the type of the land is very important. You see that you install a thermal power plant, then you need that the land should be at the cheaper rate, because you need a lot land, or the good amount of the land to create or to install a thermal power plant. That's one of the concern. Another concern is that your bearing capacity of land should also be good, because you will install the heavy machineries, heavy turbine, heavy generator. So it should be that the bearing capacity should be very high, so that those machines can be installed and they do not vibrate when these machines run. Okay, because they are generating if 3000 and 4000 megawatt, then you can expect that what kind of the, and they are running on the 3000 rpm revolutions per minute. If I talk about the thermal power plant and hydropower plant, they run on the 1500 rpm. Next thing is that nearest to the load center, it is not practically possible, because you see that most of the thermal power plant are near to, or they are always installed in a remote location. They are near, sorry, mute your mics. So they are near to basically the coal mines. Okay, it's not possible that they can be near to the load center, but this point has been put here that if they are near to the load center, then first thing is that your transmission cost, your installation of transmission line, you will be able to save some cost on the transmission line. At the same time, transmission lines have some losses, so you will be able to overcome those losses if your thermal power plant is near to the load center. Another concern is that distance from the populated area. As we have seen that the flue gases will be finally discharged into the atmosphere, but it's not possible to filter those flue gases 100% with accuracy. So that is why the thermal power plants, they create a pollution into the atmosphere. So it's better that it should be away from the populated areas, considering the safety and the health of the humans. So with this, I believe then your thermal power plants is completed. Only now we discuss only two things, that is efficiency of steam power plant. Now what do you mean by the thermal efficiency? Thermal efficiency means it is the ratio of heat equivalent of mechanical energy transmitted to turbine shaft to the heat of coal combustion. Okay, what it means? It means that if 100 calorie of the coal use, so for example the 100 calories you are getting the energy from the coal, then only 30% of that is available at the output of the shaft. Okay, rest is lost into the system. So that is will give you the thermal efficiency, the heat equivalent of mechanical energy turbine transmitted to turbine shaft, means that how much heat is available at the shaft and how much coal has been burned. So if 100% has been burned, then only 30% will reach, because rest is lost into the system, and that is why the thermal power plants, they have the lower efficiency in comparison to other power plant. Another concern is that if I talk about overall efficiency, then it means the heat equivalent of electrical output to the heat of combustion of coal. So it means, for example, now I'm expecting that, okay, I have burned the coal, and now I'm expecting that, okay, if from 100% I'm getting only 30%, but you see that the turbine is coupled, the turbine shaft is coupled to the alternator. Heat equivalent of electrical output. Output means you are getting an output from the generator, but your generator also have 1% of the losses. So if 100% you get from the coal, then 30% is available at the turbine shaft, then 29% will be available at the output of the generator, and that is the drawback of the thermal power plant. Okay, so that's one concern. I believe that that is sufficient for today, and we will discuss hydropower plant in next class. If you have any doubt, you can discuss with me. If no, then no problem. Students, do you have any doubt? Hey, students, you are sleeping, or I have lost the connection.
We still here, sir.
Or you are sleeping?
No, not yet.
Hey, you get bored. I believe that I have not teach such a bored thing to you, huh? Such a bored topic, huh? Or no?
No, so it's interesting.
Okay. Do you have any doubt or any queries? Do you have any questions, students? I believe that that is sufficient for today. Otherwise, you will lose your interest if we'll go into the hydropower plant also in today. Pile, do you have any questions?
Sir, if possible, can you upload the notes for pre-read for the next class?
For next class?
Yeah, so we can just pre-read it in advance, and then when you're going over it in the next class, it'll be easier to understand what you're going through.
Okay. No, you see that I do not have exact notes for first unit. I have only the PPTs. Well, I will upload this PPT for you. At the same time, for next class, in next class, I will cover the hydropower plant, nuclear and gas power plant. I will upload that lecture, okay, because I have taught this part earlier also. I have that lecture with me. I will upload that lecture which I have taught to industry guys, so you can see that lecture also, and if you have any doubt, so you can discuss with me also. Okay.
Okay, thanks, sir. And also tutorials as well. Will you give us tutorials for these sections later on?
No, it does not have too much of the numericals. In the department, these guys are full now. It totally on the concepts and other thing. Power system 2 does not have too much of the numerical problem. It has only few numerical problems, and that I will discuss with you in a class. Okay.
Okay, thanks, sir.
Yeah. Anything else? Any other question? Zaba, you can hear me? Zondi?
Yes, sir. Yes, sir. I can hear you.
Yeah, what's happening? Okay, so if you do not have a question, then thank you so much. Okay, you will be able to see this lecture later also. Okay. So I'm now, I'm just, okay. Thanks. Bye.
Thank you.
Okay, bye, sir.